Today we're going to talk about factoring special cases. There are two different special cases that we have, and the first is what we call a perfect square trinomial. So we'll talk about why it's called that here as we factor. So the first example is m squared plus 6m plus 9. And so since there is no GCF, there's not that to deal with. And then this does have a 1 in front of it, so that means that we can just go ahead and start factoring. The first two spaces need to multiply to give us m squared, so that's going to be m and m. The back two spaces of this need to multiply to give us 9. And when we do all of our math, we have to get 6. So if I have 1m and 1m here, and I'm trying to find factors of 9 that give me 6, I'm not going to choose 9 and 1. I do know that both of these are positive, and if I use a positive 3 times a positive 3, they multiply to give us 9. And those two things add together to give us 6m. So this does work, okay? The reason why it's called a perfect square trinomial is because we got the exact same binomial twice, which means we can write it as m plus 3 squared. Writing it as m plus 3 times m plus 3 is okay, and writing it as m plus 3 squared is also okay. Either one of those would be a full credit answer. Okay, so let's look at another one where we have 9x squared plus 12x plus 4. So here, this is in our perfect square trinomials unit or lesson. So that means that we're looking for something to be the exact same binomial multiplied by itself twice. So if the first two spaces have to multiply to give us 9x squared, we're going to do that by using 3x and 3x. Since it's a plus, well, we will need both positives. And the back two numbers need to multiply to give us this 4. So if we use 2 and 2, that's going to give us the exact same parentheses, which means that we can write it as 3x plus 2, that quantity squared. Okay, so either one of these is acceptable as well. All right, so that's the first special case. The second special case that we have is what's called a difference of squares. Okay. And again, we'll talk about why it's called a difference of squares here soon. So we have x squared minus 25. So this would be the same thing as us having x squared minus or even plus 0x minus 25. So we need two numbers. I guess let's start here first. The first two spaces have to give us x squared. So it's going to be x times x. The back two spaces need to give us a negative 25. And they have to add together to give us 0. Two numbers that multiply to give us negative 25 and add to give us 0. Well, that's going to happen if we have a positive 5 and a negative 5. So the difference of squares, okay, because something is being squared, in this case it's x, there's a subtraction sign, which is difference, and then 25 can be written as 5 squared. So one way to do this is literally what we just did here. Okay, the other way to do this is the square root of x squared is x and x. The square root of 25 is 5 and 5, and we know that we need one positive and one negative to make that happen. Okay, so if we look at the next one, we have x squared minus 16. So again, we know that we need x and x to give us that x squared. We need two numbers that multiply to give us negative 16 that are going to have no constant term or add together to give us 0. So it's going to happen if we have a positive 4 and a negative 4. Moving on, what happens if we have a leading coefficient that's not 1? So 4x squared minus 25. Again, we're always looking for a GCF. There is no GCF there. So we need two numbers that are going to multiply to give us 4x squared. Well, we're going to use 2x and 2x. And then we need two numbers that are going to multiply to give us negative 25, and the middle terms are going to go away. So that means that we need to have the same thing in the parentheses, just one positive and one negative. Okay. Last one, if we have x squared plus 4. So if we go to factor this, and we have x and x to give us x squared. And then it is a positive here, so we would look at a positive 2 and a positive 2. But if you actually multiply this together, x squared plus 2x plus 2x plus 4. Do those middle terms cross off this time? No, they don't. So this doesn't work at all. Is there any other way to do it? If they're both negatives, would that work? If we have x minus 2 and x minus 2, would that work? Well, that would give us x squared minus 2x plus 4. Do those middle terms go away? No, those don't either. So this is what we call a sum of squares because it's the sum of squares. We would say non-factorable for this. Okay, so a sum of squares you cannot factor, but a difference of squares you will have the same thing in the parentheses, just 1 plus and 1 minus, and that's it.